Hi guys, welcome to Not So Nerdy channel. Solving a sliding window maximum question. It's a hard question. So you are given an array of integers nums. There is a sliding window of size k, which is moving from the very left of the array to the very right. You can only see the k numbers in the window. Each time the sliding window moves right by one position. Return the max sliding window. Okay, so here is a short example to understand. You are given nums 1, 3, -1, -3, 5, 3, 6, 7, and your k is 3. So you can have a sliding window with 3 elements. So you have 1, 3, -1. You start from zeroth index. So your maximum in these 3 elements is 3. Then you move the window to the next index. You shift your right by 1 position and you get 3 -1 -3. Your maximum is again 3. And you keep on shifting and you store your maximum values and then you get your output as this. So for this, let's, according to our previous questions, like how will I think? Okay, I need to focus only on this. And I can have 2 pointers on the first left side and on the rightmost side. And then I can take a max of all the 3 elements and simply store it in some list and solve it. So that would be your basic brute force thinking. So let's solve it. Left equal to 0, your right equal to, now your right is at k -1th position, okay, and you are storing your result in some result list. Now while your right is less than the length of your nums, you are storing a max value in as max of nums. You are using the slice function, like you're using the slice thing. So from left till right +1, because right +1 because you want to include the rightmost element. So you are using left till right +1. Then you are adding it in the result. So result dot append max value, and finally you are simply increasing your right and left index, and then you are return result. So this is a valid solution actually, because you are solving it, you are using a logical approach, but your time limit has been exceeded, unfortunately. Let's show you here. See, time limit exceeded. So only 31 cases have passed out of 51. So you have to come up with another solution. So to solve this question in an optimized manner, we are going to take the help of Deque or Deque. I have explained about it in my previous video. Go through it and you'll get more clarity. So how are we going to solve this? I'm taking the same example. Now in this, you have 3, the size should be 3, right? So you start from 0th index. So it's 1, you have 1, okay? Now what do? You simply go to the next one, which is 3, right? Okay, I'll keep my 1 here, not here, okay? 3. Now 1 is less than 3. So the usage of 1 is not required. Okay, so you are going to pop this one and you are going to store the element 3. Next, you're going to the third element, which is -1. And here you are completing your window size. So -1 is also not relevant. So you're not going to store it in your window. Okay, and from this, your output will be 3. Okay, because that will be your frontmost element, right? Okay. Then you go to the next window, and in that again you get a 3, which is already there, so there won't be any comparison. Then you come to the next element, which is -1, which is not greater than 3, so it's useless. Then you go to the next element, which is -3, which is again a useless, so you are not going to consider these elements. Okay, now you go to the next window. So these two elements are already not getting the like they are not required, so you compare with 5. Now 5 is greater than 3, right? So you will pop this and have 5. Okay, now you have already stored your result from the first and the second window, which is 3 and 3. Then in the third, on reaching the third window, you get that 5 is your next maximum value, right? So then you go to the next window, which is -3, 5, and 3. Now here again 5 is your maximum, so you compare each time, like you see that okay, -3 is not greater than 5, so it's not relevant. 5 is equal to 5, so again ignored. 3 is not greater than 5, so it's again ignored. Then you go to the next window, 5, 3, 6. Now here 5, it's okay, pass. 3, we again pass. When you come to 6, now 6 is greater than 5, right? So you will remove, you'll pop the 5 and you'll have 6 in your deck. So again, your results were stored as 3, 3, 5, 5, and then now your result will be stored as 6. Okay, then you will go to the next window, the last window, which is 3, 6, and 7, and you'll get that your 6 will be popped and your answer will be 7, and you'll add that in your output. It sounds like a little complex. It's coding, like I'll try to explain while coding. Okay, let's start. So you have, suppose you're storing the length, okay, in num n. Now you have your, if n equal to 0, it will be n equal to 0 means your length of nums is 0, so you will simply return an empty list, right? Okay. Now if your k equal to 1, you're going to return nums itself, because window size is 1, so every element is maximum in its own. Now you will declare a deque called q, so deque. Okay, and you will again, and we will have a result to show, which will be a list. Great. Now you have, for I in range n, you are going through every element. So here, okay, so as I said, with each element we'll check whether the current element is greater than the element which is already there in deque or not. So while q exists, like, and q like nums of q of -1, because we are checking the like rightmost element, right? So if this element is less than your current element, which is nums of I. Now if this element which is already there in deque, it's less than the element you are comparing it with, your current element, then what were we doing? We were popping it out. So we were doing q dot pop, and we were going to append our current element. So q dot append I. Okay. Now each time we were storing our result as well. So how are we storing it? We are storing the leftmost element every time, right? So if I is if I is so I is your current index, and if it's greater than or equal to your window's length minus the 1, you will append your result. Oh, sorry. Nums q0. So here we are appending the frontmost element in our result each time. And when are we appending? When our current index. See, Deque is storing the indexes of the elements, right? So here in this case, we are storing our indexes in the Deque, and we are accessing our elements via nums like this. So here your index I, your ith index, your current index, if it's greater or equal to your k minus 1, your window length minus 1, then you are appending the like suppose suppose you have 1 2 3 4. Okay, your I is say 2, your current element, which is 3, like 3 is your element here. Okay, and if k is 2, let's say k's value is 2, so here k minus 1 would be equal to 1. So if I is greater than 1, now like I is greater than this element, we can see. Why are we going? Because we are checking that whether your current element is outside the window, has it gone to the next one, so we can store the result of the current window, right? Your current window, your k is sorry, k here is 2, right? 2, yeah. So here your I is 2. It's already at 3 now. So for the previous window, which was of 1 and 2, you have to store the maximum value. That is why you are appending the result now. Okay. You'll store the result when you have gone to the next element. Okay. So yeah. And this is for storing your result. Storing the result. Now this is for okay, now you have to remove the element which is outside the window, right? So you will remove element outside the window. So how will you do that? So while q and your q of 0, if it's less than your I minus k plus 1, q of 0 is less than I minus k plus 1, so you are going to remove your leftmost element, pop left. So these are the 3 basic steps that you are going to do. You're going to remove the element which is outside the window, you are going to store the result, and you are going to remove elements which are smaller than the current element. Okay. Finally, you are going to return your result. So return result. Okay, let's try running this. Okay. Okay. Well, so firstly, I think why this issue came is because we can see that, okay, you are removing your elements. Great. I think because you have to store your result in the end. You don't have to like change the window first and then store your result. It's gonna give you a wrong answer, right? First, you have to remove the element and then you have to store the result. You can even change it and keep it after this, and it's still going to give you the answer because storing the result would be at the end, right? Great. Okay. So I hope you understood this, and if you have any doubts, I know this is a little confusing to understand. Just remember that we are storing the indexes in the deck, okay, not the elements, and using those indexes, we are solving this question. You can rerun this, you can look at the other videos to understand in a better manner. And yeah, thank you. Bye bye.